Hi, everybody. My name is Fraser King from the University of Waterloo. I'm a PhD candidate studying snow. And today I'm going to be talking about using LiDAR to estimate snow depth using portable consumer devices and how this relates to citizen science. So a little bit of motivation before we get going. How much snow is here if I was going to ask you that, just looking at this picture? It's a difficult question, right? You can go out there, you can stick a ruler in the ground, but as we can see from this image, the depth of the snow varies quite wildly, even over a few meters. And you have to also be careful of the local wildlife when you're taking in situ measurements this way. Traditional LiDAR is another option, thinking about using something like a total station. However, this is often expensive and it's not something that the average consumer or person would have access to. And so there's this idea that we can use LiDAR to help estimate snow. And so this remote sensing technique, where we observe from a distance, is shown here from the paper by Deems et al. The idea is you take a snow on ground measurement and you take a snow free measurement. And by doing some filtering and some grid subtractions and interpolation, you can get an idea of how much snow has accumulated over that period of time. As you can see in the example on the right, you can then model this and get a fairly accurate representation of snow on ground. So traditionally, we would use sensors from things like the total stations or on satellites, but more recently, technology has evolved to a point where you can actually get pretty good LiDAR modules in your phones. And so this is an image here of the new iPhone 12 Pro, which is equipped with a image sensor die LiDAR and a depth framework, which allows you to record a whole bunch of high resolution information throughout the entire field of view from the camera. It works in nanoseconds. It's been told to have an accuracy of about approximately 5 millimeters and a range of 5 to 10 meters. So for mapping a small area, we thought it would be potentially a good instrument to investigate here. And so I went out and purchased iPhone 12 Pro to do some tests with. And I'm showing a real-time visualization of what this looks like in my backyard on the patio for a snow-free observation. You can see from the video here as I move around, things closer to me are that deeper purple and further away are being mapped in that light blue. You can see the LiDAR picks up the ground, the table edges, the fence, parts of the tree and the stairs with a fairly high degree of accuracy. And this is just a basic app that I'm using on the phone, which I'm assuming will improve over time as well and just get more accurate. But you can really map out the entire scene quite quickly just by walking around with your phone. There's no need for any specialized equipment to do this. And I'm using this scene here as a baseline for my measurements that I'll talk about in the future here. So doing this simple test, as you saw in the video on the left for my patio, what I first wanted to do to get an idea of how accurate this LiDAR was just do a test with a simple box. So I measured the box dimensions. I found it was 31 by 30 by 23. I set it on the table after I took my baseline measurement, and I performed another recording using the LiDAR. And I'm showing the results of that test here. You can see on the left the no snow baseline measurement. I've just interpolated the approximately 10,000 points, which composes the table surface there across the approximate 1 meter squared region. And on the right, you can see this is a top-down view, of course. The box sitting in the very center of the table with a height that's sort of in this light green color, which is sitting around 30 to 35 centimeters here, which is approximately what we measured the box to be before. If I subtract these two, we can actually pull out this Z difference to get the height measurement here. And as you can see, if I move my camera from the image on the right, the histogram of depth measurements across this range, we can see where I've highlighted here around 0.3, we're actually grabbing that box information, which is great. We're seeing that come up on the histogram here and getting an estimate of approximately, at that max height, 32 centimeters, as you can see, which is what we measured the box to be beforehand. So that's really positive as a first test. However, as I move my camera back, we're interested in snow, right? Not boxes. So I decided to move forward with this experiment. I'm still going to use my test site on the left, the table in my backyard, but I've also done a more representative example, which might be used by regular people with phones where they've just got a backyard, and they're interested in how much snow is accumulating there. So I set up a simple sort of snow field experiment on the right there. And so these were the snow-free observations I took, and then I waited for it to snow. It did actually snow quite a bit this year in southern Ontario, which was great. And so I was able to get some really rich information and detailed observations to test this experiment with. So to get in some of the results, this was the snow-free scan for the backyard snow stake experiment I set up. It's about a 2.5 square meter region. One of the really interesting things, if I show you the actual depth map here, is the LiDAR was able to actually capture some of the small bumps on the surface topography, which is really interesting. You can see sort of within the stakes here, the actual little bumps that were present in the ground just from the grass and the dirt clumping. So you get really high accurate estimates just by walking around the scene. And to show the results that we had from both test sites, I've got that pulled up here. And so on the left, we've got the table, a time series from the end of December to the sort of mid-March, which was the snow season here in southern Ontario, and the snow depth on the y-axis in meters. And I have the backyard estimates on the right. And so the table estimates I took daily. So these are pretty much daily observations. I missed one day, I think, in January, but I was pretty consistent with the in situ measurements using just a regular snow stake in red and the LiDAR estimates in blue. And similarly for the backyard, the only difference here is I started the experiment a slight bit later in mid-January, and I took observations biweekly. And so as you can see from the results, we actually get fairly high estimates, or fairly high accuracy, sorry, using the LiDAR when compared to in situ measurements. Not only are correlations quite high, above 0.99, the RMSE is approximately what is suggested to be the limitations by the phone from Apple, which is around 5 millimeters. We can see the bias is basically non-existent in both cases when we look at the average over the full period. And so overall, when we see increases in one, we see increases in the other, and the accuracy was actually much better than what I was expecting to see just from walking around these sites with the phone. No really in-depth zooming or anything like that was required to get this sort of accuracy, which is a very good sign, I think, for this sort of technique. Just an example of what this looks like when we're examining the actual interpolated Z differences for the different sites. On the left, I've got the Z differences for the table site. You can actually see as we move to the brighter colors there, a snowdrift which had formed on it after a few days. This took place in mid-February, February 20th, after some accumulation. And so you can actually pick that up in the LiDAR retrievals, which is really interesting. It's pretty cool that you can see that there in the image. And it also comes through with the depth measurement distributions we have on the right. This is a histogram of the 10,000 points that are taken on the left here. And you can see the grouping and the slow increase in that histogram towards that sort of 30 centimeter mark, where you're at the mode estimate across the table of snow depth, which is where my measurement, my in situ measurement suggested the snow depth was as well. And if we're looking at the backyard test here, you can see for February 22nd, so this is just a few days after the other example, you can see on the left the interpolated Z differences between the snow stakes, and on the right a very similar snow depth measurement distribution over that area. Very, very neat that you can actually see on the left the hops of a bunny rabbit that walked through my experiment. And you can see on the right a very tight histogram where, since we have many more points to work with over a slightly larger region like this, you get a much more accurate estimate, which is shown by the histogram and all of the groupings of the mean, median, and mode measurements, which all sort of sit around the in situ measurements I took with again, just a snow ruler at the site. So again, we're seeing very high accuracy in this distribution here. Some insights, if we do a scatter plot, this is just showing again the very similar estimates we get between in situ snow depth on the X and the LiDAR snow depth estimates on the Y-axis. In red is the table, and in blue is the backyard. We see similar positive agreement from both sites at both locations. It's really interesting. As I was doing this experiment, to see groups of melt and accumulation occurring. So you could actually see these little groups that occur, for instance, at the bottom, and then it would jump up after a snowfall event, or they would both move down after a melt event occurred. It was cool to kind of see the evolution of the snowpack that is tracked in the information that we're plotting here. Just want to finish off with some limitations and challenges that I encountered during this technique. As you can see on the right, I'll start with that one. The presence of local critters is something that popped up time and time again. It's not something you can really account for or control too much in this area, just because we're home to many bunnies and squirrels and such that made their homes nearby. So that's something to keep in mind when you're taking measurements, and this was showing up in the LiDAR, which was pretty interesting. Poor nighttime performance was something I noticed. So if you're trying to do this at night, it seems like the LiDAR has a tough time sort of tracking where its position is relative to the scene. And that might be something they fix in a later patch. I'm not entirely sure, but something to note for now. Mesh alignment is something to keep in mind, right? It's very important when you're actually aligning things between your observations and your baseline measurement that you're doing so properly, because any differences between that in that alignment step will cause an increase or decrease in snow depth. And finally, attention to detail. So one thing that I noticed was I'm using the snow stakes surrounding the snow site as the reference points to align the mesh. And I noticed snow was also accumulating on those, and that would sort of alter or bias my estimate. And so I had to make sure before I would do any sort of observation that the site was in pristine condition. So that's me. I think I was pretty pleased with this experiment here. We found that we had some highly accurate results within approximately 5 millimeters of the true snow depth, and it worked over this full range, which was great to see. This is a very easy technique, like I said, for anyone with a phone to use. You just whip up your phone, you walk around the scene once, and you get a measurement. You don't need to do any extra work, which is great. You don't need to, zoom in or get right in there or anything along those lines. It can work for, like I said, up to a distance of about 5 meters or so. And it's a much cheaper technique to traditional methods. And so I'm finally kind of thinking with the citizen science aspect of this is tying this into an app, which could be available to anyone with a LiDAR module on their phone. This could be done automatically with some post-processing steps within the app that then uploads that snow depth value to some sort of cluster network, which could then be distributed and used for highly accurate in situ snow depth measurements throughout the region. And so this is something we're thinking about and hoping to move forward with as we continue to refine this technique that we're talking about here. So I'd just like to thank everybody. Again, I'm from the University of Waterloo, and I'm happy to take any questions that you've got. Thank you.